there's maybe possibility in stopping the cells from dividing, and rather than maybe some cure that you'll find in the Amazon rainforest. So yeah, I wanted to ask kind of like what is the what do you think is the possibility of curing cancer with science in the future?
Yeah, so actually I'm going back again. I promise I'm not like advertising this P53 book. It's just because I happened to read it a few days ago. They actually ended the book saying, like, quoting a scientist saying, "My kids are 21, 22 years old, and I don't think they're ever going to have to deal with cancer in their lifetimes." I'm not that optimistic. I think we're making amazing progress. We're figuring out there's going to be a lot more of a push into individualized, personalized medicines for cancer therapeutics, because each cancer is so broad. Like, when we talk about cancer, cancer is literally just the dividing of cells, and most of that really matters on where specifically it's happening, what mutation is causing those cells to be rapidly dividing. And so being able to sequence everything that's going on in that tumor, and then figuring out, what specific mutation's happening, and then targeting that mutation is how we're going to be able to cure cancer down the line. And I mean, I still think CRISPR-Cas9 is going to be an amazing therapeutic for all of that. I'd like to say, I don't want to be that optimistic where I'm like, in our lifetime, no one's going to be dying of cancer anymore. Even if we have all the technology and tools at our fingertips, I think there's enough of a disparity, unfortunately, with how technology gets distributed, that we're going to be dealing with this for a while going forward. But I think we're already getting to the point where a lot of cancer is becoming, from near death sentence to you've got 5 years, you're going to have to be dealing with terrible treatments and stuff, but then you're going to have a healthy life afterwards. So I'm optimistic enough to say that we are going to be able to treat it. I think a lot of things are already becoming more treatable. Do I think it's going to become an obsolete talking point? I don't think so. I think there's a lot that we still need to do in that front.
But like, if you discover the cells before they divide too rapidly, and then we have the technology, in theory, can we like stop the cells from dividing?
Yeah. So in theory, right. In theory, a lot of cool. Like, we could, if we figure out, like, okay, it's this specific mutation in this person, send in something and fix that mutation. Or, I mean, what we've seen a lot of people do is, if you catch it early enough, you just scoop it out, and that's before. So when I was talking about a lot of cells, the issue becoming metastasizing is because once cancer cells, say if you've got, let's say breast cancer, once you've got those cells dividing rapidly, you're going to have a subpopulation that's going to go dormant. And so even if you scoop out that breast cancer tissue and you get rid of all of those actively dividing cells, unfortunately there's a very high chance there's going to be a dormant population. And why that dormant cancer cells are so important is because all the drugs that are on the market for cancer cells target actively dividing cells. And that's because the hallmark of cancer cells is the ones that actively divide very fast. I mean, that's why I'm saying chemotherapy is killing actively dividing cells. That's why you also lose all your hair, because it's not just targeting cancer cells, it's targeting anything that's actively, rapidly dividing. So we've got a lot of things like our hair is rapidly creating new cells to create new hair follicles for us. So if we're able to take technology and take it one step further, not just targeting actively dividing cancer cells, but cancer cells with that specific mutation that those cancer cells are doing. I mean, right, what you said, we stop it before it even starts.
Wow.
And that, I mean, long term, that would be the goal, right? You'd get your sequenced genome now as a baby, then maybe get at 18. It might be like a routine doctor's appointment. I'm getting really excited, because I think that could be, if we had the resources, the technology, and the funding, we are getting to the day, like back when the human genome was first sequenced in early 2000, that cost, billions of dollars. It was a huge, super expensive project, right? Over decades. And now we're getting to the point where I can spend $70 in the lab and send something off to be sequenced in a day. We're able to make things so much more cost effective, where I would love to say that one day we'd be able to get to that. I think it goes more into the faith of humanity being able to distribute that technology effectively.
No, that's amazing, and that's really like hopeful.